Saxon Algebra 2, Lesson 112. Kaboom. It's very bold of me to cross it off before I actually teach it. What if a meteor hit me? What if it just like came in my dining room window right now, killed me flat, and I didn't teach this lesson, but I checked it off on my checklist? That would be bad. All right, these are the less thans. Remember I told you the other day when we did the greater thans that we would soon be coming back? Here, let me find it. Here it is. Right, we did the greater thans, and it's this whole thing with the pluses and minuses, and I told you it would be confusing, but we would do the other side, and hopefully it will be better. Today's the day. Okay, so let me write down the problem. It looks a lot the same. The instructions say solve this inequality and graph its solution on a number line. Okay. And just like last time, John is nice and he gives us the first problem with the quadratic already factored. And the domain equals the reals, which you probably know. That's my favorite. Integers and the dots, they annoy me, but I like the reals because they're just circles and arrows. You color it in or you don't. Okay, so this is already factored, so that's step number one. And we notice that this time, our inequality is pointing to say that this big thing is less than 0. Okay, that means we want the product to be a negative number. Last time we wanted the product to be a positive number. This time we want it to be negative. Okay, we know that when we are multiplying two numbers together, if we want it to be negative, then one should be negative and one should be positive, right? This can be negative and this positive, or we can vice versa, right? We can have the first, whatever I just said. We do the opposite, right? If we want it to be a positive product, then it's either both positive or both negative. But if we want the product to be negative, it's a mashup. I've confused myself. I've said that so many times. So we want either this one positive and that one negative, or vice versa, this one negative and this one positive. So this is what we're gonna build our two scenarios on, is this combination. Forget about the P and the R. They shouldn't be in my puffy cloud, but they are. These are the two scenarios that we're gonna develop. Last time, let me just show you. Last time we were developing the two positives or the two negatives. This time we're developing the mashup. I put first plus minus and then the second will be minus plus. It doesn't matter if you reverse those. As long as you've got the scenario set where one is positive and one is negative, the order you do this in doesn't matter. It didn't matter here either. We could have done two negatives and two positives. It doesn't matter. Okay, now we don't think about this inequality anymore. It has done its job. It helped us develop these two scenarios. Now we're gonna let these plus and minus signs help us develop the scenarios underneath them. In this one, we want the first binomial to be positive. That means that x minus 2, plus 2, has to be greater than 0, because we want it to be a positive number, right? And that means that x minus 3 needs to be less than 0 because we need it to be a negative number, right? We're not paying attention to this anymore. We're only paying attention to these little dudes. And they're telling us how to set these up. Same thing over here. This says x plus 2 needs to be less than 0 because it's negative. And here we want the positive, so it's x minus 3 is greater than 0. All right? So these four little signs determined how we've set up these inequalities. It has nothing to do with this. This led us to this, and then these lead us to these. Clear as mud, right? Okay, now we do our quick little algebra. X is greater than minus 2. X is less than positive 3, right? I'm just flipping them around. X is less than negative 2. X is greater than 3. Okay, just like we did the last time, We're going to graph them separately, and then we're going to look at the combined effect. And just like last time, we'll be able to shortcut it, but we're going to do the two number lines separately first. All right. It's real numbers. We want numbers for x that are greater than 2 and less than 3. So here's my -2. Here's my 3. There's no equal signs on these, so I know it's an open circle for both. And the overlap will be this area, right? It's true that x greater than -2, it keeps going, but I don't want all those values because x is less than 3 goes this way. We only want the overlap, right? So there's my solution for this. Now I do x is less than -2 and x is greater than -3 or +3. But look, there's no overlap. There's no overlap. There's no place on here where both of these solutions are true. Here, I want to just draw this a little bit better so you can see. The +2 keeps going that way, and the -3 goes this way, right? And we only chose to show on our graph the parts where they overlap. Here, they don't overlap at all. There's no overlap. So we can say on this side, there's no solution. Because the numbers that work for this binomial don't work for that one. So there's no solution. This is a no bueno scenario. This then is the final answer for our problem. We don't have to make a combined one. When the inequalities are less than inequalities, we'll always get this pattern. One will work out, the other one, there's no overlap. Yeah, we could graph those separately, but we need both of them to be true in order for this whole scenario to work. So if they don't overlap, then there's no solution on that side. And this is the only real solution. Clear as mud, right? Let's do another one. I think there's just two. I said clear as mud twice in this lesson. Oh, that's unusual. Okay. Fresh page. Ready? Example 112.2. Solve this inequality and graph its solution on a number line. And once again, John does the little thing of saying, I made it easy for you the first time, but not this time. Domain equals the integers. Fine. I'm abbreviating that to just int. Okay, so this time we have to do our own factoring. I mean, that's really the least of our problems, right? Two numbers that multiply to -8 and add to +2. Let's see, that would be x plus 4 and x minus 2, right? Double checking, -8, +2. Okay, good. So there we go. We have our binomials. That's what we need in order to go ahead. And we know that this one can be positive and that one negative. That'll give us a negative number, which is what we need. Or we can do it this way, right? So I set up those two scenarios. And now I'm not thinking about this anymore. I'm thinking, okay, I want the first binomial to be positive. So that would be x plus 4 is greater than 0. I want the second one to be negative. So that's x minus 2 is less than 0. Then I do the same thinking process over here. I want the first binomial to be negative. So it would be x plus 4 is less than 0. And then I want the second one to be positive. Look how crooked my plus sign is. I want my second one to be positive. Now it just looks like an asterisk, doesn't it, here? X minus 2 is greater than 0. Okay. Quick algebra. X is greater than -4. X is less than 2. X is less than -4. X is greater than 2. Once you get the hang of these, you can even rule them out by looking at them. X is greater than -4 and less than 2. Okay, I can see there's going to be overlap on this one, right? It's greater than -4, -3, -2, -1, 1, 2. Gonna have to borrow a little space. Greater than -4 means I start going this way, but I don't include, whether or not we have an equal sign is driven by that, okay? If this is just a plain inequality without the equal to, then we use the same for everything. If there was an equal sign under that one, then it's used for everything, all right? So there's no, you don't have to think about that. Just copy the form of that one. Okay, and then x is less than 2. I'm gonna put those dots below, and they go this way, right? So that means I want the place where they overlap, which is like that. Oh, I shouldn't have colored that in because that includes all the reals. My bad. It would just be these spots, right? -3, -2, -1, 0, 1. Yes. Okay, so ignore my, it looks like I graphed the real numbers when I really just want the integers. So it should just be those spots. I should just have a regular dot there. And I can see right away, this isn't gonna work because what numbers are less than -4, but also greater than 2? There's no overlap, right? It's like this. And while that looks like an answer in some, that's a disjunction, we need our values for x to satisfy both of these conditions at once, and they don't. So this side is no solution. And this side is the full answer. Now, I do want to point out that in our scenario, in both cases, the proper solution was on the left and the no solution was on the right. That's just coincidence. There's no pattern, there's no rule that it will always be that way. So don't let that fool you, okay? This was driven by the order I wrote my binomials, right? So don't worry about that. Don't try to deduce any wisdom from that. The most important thing is recognize what pattern you need up here of positive and negative factors to get the product you need, and then use this to set up these two and go from there. All right, hopefully this lesson makes lesson 110 feel a little bit better in your brain, because I'm all for having a comfortable brain. Okay, I'm done. Goodbye.